There are moments in science when a machine stops feeling like a tool and starts feeling like a doorway. Quantum computing was never supposed to be ordinary. It was built to explore problems so complex that classical computers could spend thousands of years trying to solve them. But what happens when those machines begin exploring the deepest structures of reality itself? Far beyond the visible world, beneath atoms and particles, nature follows rules that seem almost unreal. Particles exist in multiple states at once. Distant objects appear connected across space. Reality becomes probability. Quantum computers are built inside that strange world. Unlike ordinary computers that process information as zeros and ones, quantum systems use qubits, allowing calculations to unfold across countless possibilities simultaneously. This changes everything. Scientists believe future quantum systems could transform medicine, simulate new materials, unlock unknown chemistry, and reveal hidden patterns inside the universe itself. But the deeper researchers push into quantum territory, the stranger the questions become. What if reality is more layered than we imagined? What if space itself contains structures we have never observed? Across the cosmos, galaxies drift through an expanding universe. Black holes bend spacetime. Invisible dark matter shapes entire clusters of stars. Yet most of the universe remains unknown. Quantum technology may become one of humanity's most powerful tools for exploring these mysteries. Some physicists believe advanced simulations could help model the earliest moments after the birth of the universe. Others believe quantum systems may reveal hidden behaviors inside matter and energy that classical science cannot easily reach. This is where science begins to feel almost philosophical. Because understanding the universe is no longer just about looking outward into space. It is also about looking inward, into the microscopic foundations of existence. Every atom, every particle, every field, all connected to the architecture of reality. Modern quantum processors are already crossing milestones once thought decades away. Improved error correction, greater stability, more reliable entanglement. Each step moves humanity closer to machines capable of exploring problems beyond classical limits. And the implications reach far beyond computing. New materials, advanced energy systems, molecular discoveries, deeper cosmological simulations, possibly even insights into how spacetime itself behaves. Imagine a future where quantum models recreate the birth of stars, simulate black holes, map the hidden structure of the cosmos, or reveal laws of nature still waiting in the dark. Because space is not empty. It is filled with unanswered questions. And quantum technology may become the language we use to ask them. For centuries humanity explored the universe with telescopes. Now we may explore it with computation. Not by traveling through space, but by understanding the rules that built it. The next revolution may not begin on a distant planet. It may begin inside a quantum processor. And if that happens, the future will not simply be faster. It will be stranger. Humanity has always believed that the edge of knowledge was somewhere far away. Beyond the oceans. Beyond the mountains. Beyond the stars. But quantum science suggests something unexpected. The greatest frontier may exist beneath reality itself. Hidden under every atom. Inside every particle. Within the invisible framework holding the universe together. The universe appears calm when viewed from a distance. Galaxies rotate in silence. Stars burn across billions of years. Nebulae drift through endless darkness. Yet beneath that calm surface exists a world of constant motion. Particles appear and disappear. Energy fluctuates. Space itself vibrates with invisible activity. Quantum mechanics revealed that reality is not fixed. It is dynamic, probabilistic, stranger than imagination. And now humanity is learning to work inside that world. Future quantum systems may allow scientists to simulate environments impossible to recreate physically. The interior of neutron stars. The first moments after cosmic inflation. Extreme gravitational conditions near black holes. Even the evolution of matter in the early universe. These are not ordinary calculations. They are windows into cosmic history. Every answer leads to larger questions. What existed before the first stars? How did structure emerge from chaos? Why does the universe follow mathematical laws at all? The deeper science travels, the more mysterious reality becomes. Some researchers believe information itself could be fundamental. Not matter. Not energy. Information. A hidden layer beneath physical existence. If true, then understanding computation may become essential to understanding the cosmos. Quantum technology could become more than engineering. It could become exploration. A telescope pointed inward. Searching not across space, but through the foundations of existence. Imagine future observatories linked with quantum systems. Mapping gravitational waves. Simulating dark matter interactions. Studying regions where spacetime bends beyond ordinary intuition. The boundary between physics and computation may slowly disappear. And with it, our old picture of reality. Because the universe may not be a static place. It may be an unfolding process. A cosmic system still revealing its rules. For thousands of years humanity looked at the night sky and wondered what was out there. Now a different question is emerging. What is underneath everything? What hidden structure supports space, time, matter, and consciousness itself? Quantum science has not answered these questions. But it has opened the door. And once a door opens, history rarely turns back. The next era of discovery may not begin with rockets crossing the stars. It may begin with understanding the invisible code written into the universe itself. And somewhere inside that code, the future may already be waiting. Far beyond the reach of planets and stars, the universe carries a silence that feels almost endless. Yet that silence may be an illusion. Because everywhere scientists look, reality appears filled with hidden activity. Space bends. Time stretches. Particles emerge from emptiness and vanish again. Even the vacuum of space is not truly empty. It is alive with fluctuations beyond human senses. For centuries these mysteries remained untouchable. Humanity could observe them, measure them, theorize about them, but never truly explore them. Quantum technology may change that. Not by taking us physically across the cosmos, but by allowing us to recreate pieces of cosmic behavior inside computation itself. Imagine simulating the environment near a black hole. Watching matter twist around extreme gravity. Recreating the first microseconds after the universe was born. Following the formation of the earliest particles. These are questions too vast for ordinary machines. Yet quantum systems are beginning to move toward that frontier. And with every advance, the scale of possibility grows. Because understanding the universe changes more than science. It changes perspective. The stars stop feeling distant. The cosmos stops feeling separate. Everything becomes connected. Atoms inside our bodies. Elements forged inside exploding stars. Particles moving through ancient cosmic fields. We are not outside the universe. We are part of its process. A continuation of it. Perhaps that is why the search matters so much. Because every discovery is also a mirror. The more we understand reality, the more we understand ourselves. Somewhere in deep space, galaxies continue drifting through darkness. Ancient light still travels toward Earth after billions of years. Black holes remain hidden beyond event horizons. Dark matter still shapes structures we cannot fully see. The universe keeps its secrets. But not forever. Human curiosity has crossed oceans, reached the moon, sent machines beyond the solar system. And now it is moving inward, into the quantum foundations beneath reality itself. This journey has no map. No final destination. Only questions. And perhaps that is exactly what makes it beautiful. Because the universe was never simply waiting to be observed. It was waiting to be understood. And the next chapter may already be beginning. Not among the stars alone, but inside the invisible world that created them.